Welcome to qnawire.
So now we'll work on problem 102 from chapter 20. In this problem, we're told that a voltaic cell is constructed that uses the following half-cell reactions. Copper 1 to copper and iodine 2 going to iodine minus. The cell is operated at 298 Kelvin with concentration of copper is 0.25 and iodide at 0.035 molar. Determine E for the cell at these concentrations. So we can go ahead and write down the overall reaction here. We have I2 plus 2 copper will produce 2I minus plus 2 copper plus. And our E value here will be 0.54 minus 0.52 equal to 0.02 volts. So now we have to take into account the conditions that are specified. So E is equal to E naught minus 0.0592 divided by N times the log of Q. So all of this here is equal to 0.02 minus 0.0592 divided by 2, since we're transferring 2 electrons in this reaction. Then we get the log, and this is an unusual situation because both of the soluble compounds are on the product side. So in the log here we have multiplication, not division. So we multiply these two concentrations. And when we do this, we get a value of 0.08 volts. So in part B, they ask us which electrode is the anode of the cell. So the anode is the one where oxidation is taking place. It's also the one with the lower reduction potential. And both of those criterion point to the copper electrode as being the anode. In part C, they ask us, is the answer to part B the same as it would be if the cell were operated under standard conditions? And since we already calculated the value under standard conditions, which we saw here, then yes, that is true. And finally, in part D, they ask us if copper plus were equal to 0.15 molar, at what concentration of I minus would the cell have 0 potential? So here they're asking about a situation in which E is equal to 0. So we can go ahead and set up the Nernst equation again, 0.02 minus 0.0592 divided by 2 times the log of 0.15 times iodide concentration. So we can solve this equation here for iodide concentration by subtracting 0.02 from both sides, then multiplying by -2 over 0.0592 and taking the antilog, and when we do that we get a value of 32 molar. So a very high concentration necessary to reduce this to 0.